So we have Newton's law of cooling. We are told that K is 0.125 and the ambient temperature is 0. And so this is a separable differential equation. Here we can also distribute to make this a lot simpler too. This is dt over d little t. That equals, this is going to be 0, and this is negative 0.125 capital T. And so we can separate it so that we have capital T on the left, lowercase t on the right, even though there's no lowercase t terms. We can divide this from both sides. So we've got negative 1 over 0.125 t in the denominator there with respect to t, and then we multiplied that dt to both sides. So dt times 1 is just dt. Then if we make that easier, isn't that just 8? 1 divided by 0.2. Yeah, so this is negative 8 dt equals d little t. And so now we can find the antiderivative of both sides. So we're taking an integral of both sides, an indefinite integral. Oh, sorry, but t is in the denominator. I missed that. I was going to say, what's happening here? So t is still in the denominator. We take an indefinite integral of both sides. We get negative 8 natural log t plus some constant c equals t. And then I just put one constant c because if you subtract this constant c from both sides, an arbitrary constant subtracted by another arbitrary constant is just a new arbitrary constant, right? Okay, so we have an equation now that can relate capital T and lowercase t. Sorry, restarting because I had did some math wrong at some point, had a miscalculation. So at this point, we want to figure out what the constant c is, so we can plug in this initial value information that capital T is 70 when lowercase t is 0. So this is negative 8 natural log 70 equals 0 plus c. So we can figure out what c is by doing 70 natural log times 8. So it's negative 33.9 blah blah blah. And so now that we know what capital C is, we've got a complete equation. And then we can plug in T equals 4 to find out what the capital T is, what the temperature of the object is. So 4 is subtracted by that. So negative 8 natural log T equals negative 29.987. Divide that negative 8 from both sides. So we get positive 3.7489. Carry out one more decimal. And so we need to raise both sides on top of a power of e. Put both sides as a power of e to keep the equation balanced, but that gets capital T by itself. So I need this as an exponent on t, on e, I should say. So it looks like we have a temperature of 42.4571, 2 decimal places, so 42.46. So this is the temperature of the object. They're asking how much colder is the object, so how much has the temperature gone down? So we start at 70. If we subtract what its current temperature is, the object has declined 27.54 degrees. So that's the answer.